Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. In episode 95 of the Network Plus Prepcast, we explore one of the most critical components in network security: Intrusion Detection Systems and Intrusion Prevention Systems, commonly referred to as IDS and IPS. These technologies are designed to monitor, identify, and in some cases, stop malicious activity in real time. They serve as a security layer dedicated to detecting and reacting to attacks that target data in transit. With threats becoming more advanced and persistent, these tools help ensure network infrastructure is resilient and responsive. Their inclusion on the certification exam reflects their importance in modern network defense strategies. IDS and IPS devices are frequently mentioned throughout the exam because they are essential elements in a layered security approach. You'll see them referenced in questions involving network monitoring, attack detection, and security infrastructure design. They may appear in network diagrams as inline devices, passive sensors, or integrated features in unified threat management systems. Recognizing their placement and purpose is crucial. Whether you're identifying suspicious traffic patterns or analyzing response mechanisms, you need to understand how these tools function and interact with the broader network environment. An intrusion detection system operates by observing network traffic passively. It monitors data as it flows across the network and identifies patterns or behaviors that match known threats or unusual activity. When suspicious traffic is detected, the IDS sends an alert to notify administrators. However, it does not take direct action to block the threat. Its role is observational, which means that although it provides valuable insight into potential risks, it relies on external systems or administrators to take corrective action. This passive nature defines its role within a security architecture. By contrast, an intrusion prevention system is an active security tool. It is deployed in line with the network traffic, meaning all packets must pass through it. The IPS scans this traffic in real time and makes immediate decisions about whether to allow or block each packet. If a threat is detected, it can drop the packet, reset the connection, or take other preventative measures. This proactive capability allows IPS devices to serve as gatekeepers that stop attacks before they reach critical systems. This fundamental difference between detection and prevention is frequently tested on the exam. Deployment modes for IDS and IPS differ in how they interact with the network. An IDS typically connects to a mirror port on a switch or a tap device, allowing it to see traffic without influencing it. This is known as off-path monitoring. An IPS, on the other hand, is installed in line, becoming part of the data path. Traffic must flow through the IPS to reach its destination. This inline placement allows it to block threats but also introduces the need for careful performance planning. The distinction between bridge mode and mirrored port deployment is key to understanding how these devices function. Signature-based detection is one of the most widely used methods in both IDS and IPS systems. It works by comparing traffic to a database of known attack patterns, or signatures. If a packet or sequence of packets matches a known signature, the system takes action or generates an alert. This method is highly accurate against known threats, but struggles with new or unknown attack types. Keeping the signature database updated is essential, as it directly affects the device's ability to identify current threats. Understanding this mechanism is essential for recognizing strengths and limitations in detection. Anomaly-based detection offers a more dynamic approach by establishing a baseline of normal behavior and flagging deviations from that baseline. This might include unusual traffic volume, unexpected port usage, or sudden spikes in bandwidth. Because it does not rely on predefined signatures, anomaly detection can identify previously unseen threats. However, it also carries a higher risk of false positives, where legitimate behavior is incorrectly flagged as malicious. This trade-off between sensitivity and accuracy is a common theme in detection system questions on the exam. Heuristic and behavior-based detection methods use predefined rules and dynamic evaluation to assess traffic patterns. These systems look at how packets behave, how connections are established, and how data flows over time. Rather than simply matching against a known pattern or deviation, they apply logic to determine whether the behavior suggests an attack. This makes them highly adaptable, but also more complex to configure and maintain. These systems can evolve based on new threats, making them valuable in environments where flexibility and advanced detection are required. There are also important differences between network-based and host-based detection systems. A network-based IDS or IPS monitors traffic flowing across the network, providing visibility into multiple devices simultaneously. It's useful for detecting attacks in transit, such as scans, denial of service attempts, or packet injection. A host-based system, by contrast, operates on individual devices, monitoring processes, file activity, and system logs. These two types complement each other. Network-based systems see the big picture, while host-based systems provide deeper insight into specific machines. The exam may ask you to compare or choose between these approaches based on context. Performance is a major consideration when deploying IDS and IPS devices. Because they analyze traffic in real time, they must be able to handle the full volume of network throughput without introducing unacceptable latency. Inline devices especially must maintain speed while performing deep inspection. To support this, many systems include hardware acceleration or custom chipsets that offload processing tasks. Understanding how performance requirements affect placement and device selection is critical for interpreting real-world scenarios and exam questions related to infrastructure planning. Logging and alerting capabilities are vital functions of any IDS or IPS device. When suspicious activity is detected, the system must notify security personnel through email, dashboard alerts, or integration with centralized platforms. Many detection systems connect with security information and event management tools to provide correlation, prioritization, and response automation. Logs typically include timestamps, source and destination IP addresses, the type of alert, and severity level. These logs support incident response and forensic investigation and are often referenced in compliance and audit contexts. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. One of the most important operational challenges with IPS and IDS systems is handling false positives. These occur when legitimate traffic is incorrectly flagged as malicious, creating noise in the alerting system and potentially triggering unnecessary responses. A high false positive rate can overwhelm administrators and lead to critical alerts being missed. Tuning the detection rules is necessary to reduce these alerts while maintaining adequate threat coverage. This tuning process includes refining thresholds, updating signatures, and suppressing known benign behaviors. Finding the right balance between sensitivity and precision is a key element in effective system configuration. The placement of IDS and IPS devices directly influences how much traffic they can monitor or control. These devices may be positioned at the network perimeter, between internal segments, or at the core. An IDS placed on a mirrored port near a firewall can monitor inbound and outbound traffic without affecting flow. An IPS, when placed inline, enforces security decisions directly but can become a bottleneck if not properly provisioned. Inline deployment offers active defense, while passive monitoring supports detailed analysis. Choosing the right placement depends on the threat model and required level of control. Response actions are what differentiate IPS from IDS at a functional level. When an IPS detects a threat, it can immediately drop malicious packets to prevent delivery. It may also reset connections to disrupt ongoing sessions or temporarily block IP addresses that exhibit attack patterns. These actions are configurable and may be automated or require administrative approval. The IDS, by contrast, is limited to generating alerts and logging events. For the exam, you must understand the types of automated responses an IPS can take and the implications for network traffic flow. Despite their benefits, detection systems are not without limitations. One major challenge is encrypted traffic. When network communications are protected by strong encryption, IPS and IDS systems may be unable to inspect the contents of packets. This blind spot can allow threats to pass unnoticed. Attackers may also use evasion techniques, such as packet fragmentation or obfuscation, to bypass detection. Finally, these systems must scale with the network. As traffic volumes increase, maintaining inspection performance becomes difficult. The exam may ask about these challenges and how they affect detection system effectiveness. Regular maintenance and updates are critical to keeping IPS and IDS systems effective. Signature databases must be updated frequently to stay current with emerging threats. System firmware and software must also be patched to close vulnerabilities that could be exploited. In addition, policies and rules need to be audited regularly to reflect changes in the network environment and user behavior. Neglecting these tasks can lead to detection gaps or false confidence in system performance. Understanding the importance of maintenance is essential for answering operational questions on the certification exam. Integration with other security tools greatly enhances the value of IPS and IDS devices. These systems often share information with firewalls, antivirus platforms, and endpoint protection software to create a coordinated defense. They can also participate in security orchestration, automation, and response ecosystems, where threat information triggers actions across multiple platforms. Centralized logging systems like security information and event management platforms gather data from these tools and provide unified visibility. Recognizing how these devices fit into a larger security strategy is key for interpreting architecture and policy scenarios on the exam. In many organizations, detection systems are a core component of compliance frameworks. Regulations and standards such as PCI DSS, HIPAA, and ISO 27001 require organizations to demonstrate the ability to detect and respond to security threats. IDS and IPS devices help meet these requirements by generating logs, documenting attempted intrusions, and providing evidence of security control. They also support audit readiness by producing alert histories and demonstrating control coverage. Understanding how detection tools support compliance objectives is a recurring theme in security exam questions. In summary, IPS and IDS systems play critical roles in modern network defense. IDS devices passively monitor for suspicious activity and generate alerts without disrupting traffic. IPS devices sit in line, actively preventing malicious packets from reaching their targets. Both rely on a variety of detection methods, including signature-based, anomaly-based, and heuristic techniques. They can be deployed at different points in the network and must be tuned and maintained to perform effectively. Their logs, alerts, and integration with other tools make them essential in layered defense strategies. To review, Intrusion Detection Systems and Intrusion Prevention Systems are differentiated by how they respond to threats. An IDS monitors traffic and sends alerts, while an IPS actively blocks malicious activity. Placement, detection techniques, performance, and maintenance all impact their effectiveness. These devices are foundational to any comprehensive security posture, and the certification exam will test your ability to recognize their roles, limitations, and deployment scenarios. Mastering this topic prepares you to protect networks from evolving threats using both passive and active defense mechanisms. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.